All right. So today we're going to talk about measurement notes. We'll talk about the metric system and the prefixes, which I'm going to make you guys memorize. We love memorizing, don't we? Yay. Okay. All right. So Unit 2 is all about measurements. Did you check this out? There's two systems of measurement. Did you know that already? There's the imperial system and there's the metric system. I think life is a bit more exciting in the imperial system. Who uses the imperial system? Yeah, U.S. and two other extremely small countries. You should, if you're interested, you should Google it sometime. It's the size of these countries is infinitesimally small. But the entire rest of the world uses the metric system, and it actually makes a heck of a lot more sense. Because the units that wind up being in the metric system have similar differences between them. Wow, we've actually got a definition of what units is. Units are a set value that's used as a standard. So a foot is a unit, right? Or if you were at the football game last weekend, a yard is a unit. They also measure inches of rainfall on a football field. Okay. The imperial system that we use here in the United States originated from a system that was based off of a king's measurements. Okay, an inch would be the distance between the knuckles on his finger. The foot would be the length of his foot, and the yard was what was measured when the king stuck his arm out, and you measured from the tip of his nose to the tip of his fingers. What happens when you get a new king? It's a new system of measurement. Okay, so it used to get a little bit messy. And one of the problems is that it's also not extremely great to use because, as we know, how many inches are in a foot? 12, right? How many feet are in a yard? 3. It's like, okay, why is it 3? How many yards are in a mile? Is it 1720? I thought that was yard. Oh, I said yards, didn't I? Right, 5,280 is the number I knew. I should have asked how many feet are in a mile. So it gets a little bit messy, right, to go between the units. All right. So this is something you probably don't need to write down the left-hand side. Another good example of why the English system is confusing is because 1 cup, the liquid measurement unit, is 8 ounces. A gallon is 128. There's 12 inches in a foot, 5,280 feet in a mile, 3 feet in a yard. There's no common difference between any two similar measurement types, like liquid measurements or length measurements. In the metric system, everything's based off powers of 10. How many millimeters are there in a centimeter? I give you hints. I just told you the answer. 10, right? How many centimeters are there in a meter? Ooh, that's a little tougher, right? There's 100. Okay, but it's all based off of powers of 10, which is a lot easier to deal with because if you have to convert from one unit to another, all you have to do is move the decimal. You just have to know how many decimal places to move it. Okay. And we've got base units. Base units is on another slide here. I've actually got a slide full of base units, so don't copy down those base units right now. So this is the prefixes. As long as you know the prefixes and you know what their meaning is, you'll be able to convert from one type of unit to another with ease just by moving the decimal. You want to write down all of these. I'm going to pause the recording here so I don't have to go through talking about them all. Milli winds up being 1/1000th. Micro, which, notice the little tail on the U here? Okay, that's the Greek letter mu. And it is 1/1,000,000th. Starting to get into tiny numbers here, right? And nano is the last one we're going to have to be responsible for, although there are other smaller ones like pico. but it's going to be 1/1000th. Which is extremely small. Nano starts getting on the size of atoms and molecules. You guys have heard of nanoparticles? The new science of nanoparticles that's been exploding for the past 5 or 7 years. Starting to talk about atoms being used for, and molecules being used for things. So the base units, you're going to want to know exactly what these base units are. So you're going to want to memorize this. I know there's test questions on it. Okay. So the base unit of length in the measurement system, the base unit of length in the metric system is going to be the meter, whose symbol is M. Now you can get you can derive things from that base unit, like you can have centimeters, you can have millimeters, you can have decimeters, you can have hectometers. Ooh, hectometers, H-A-M. That's delicious. Okay. The base unit of mass is a little bit tricky because it's the kilogram, it's not the gram. Okay, it's actually the kilogram, so it's not the most basic unit, but it is the base unit that we use. Time, we say that the base unit is seconds, abbreviated with small s. Current is the ampere, which is a capital letter A. Temperature is measured in Kelvin, which is a K, capital K. And then every chemist's favorite measurement unit, the amount of a substance. We measure that in moles, which is abbreviated as MOL. Isn't that a great abbreviation? You take off an E and you call it an abbreviation. So from there, we can get derived units. We've got basic units, right? And we can get derived units. Derived units are units that are going to be come upon by doing mathematical operations. All right, they're so basically combinations of base units. You guys already know examples of these, right? Area is a derived unit because it's length times width. And what do you get when you multiply length times width? Right, you get area. Okay. So basically, if you're talking about like 5 meters times 5 meters, what do we get? 25, not meters, meters squared, right? The units get multiplied by each other also. Having trouble drawing that too. There we go. So we get 25 meters squared out of that. Okay. What's another derived unit you guys know of? Right? All right, density is another good one. Also volume, okay? I've got this PowerPoint slide up the exact opposite order you guys gave to me. So volume is things like length times width times height, which is actually a measure of millimeters times millimeters times millimeters when we're using a graduated cylinder. What do you get when you multiply millimeters times millimeters times millimeters? You wind up getting millimeters. Millimeters cubes. Oh, you know what? I did that wrong, guys. Dang it! I can't erase that. All right, it's actually not millimeters when we're using a graduated cylinder. It is centimeters. Okay. So let me do this one more time. So it's actually centimeters times centimeters times centimeters, and we get cubic centimeters. Okay. And it turns out that 1 cubic centimeter is the exact same thing as 1 milliliter. It's probably an important conversion factor to know. Okay, and I'm actually going to go ahead and put a star next to it because it's not just probably an important conversion factor to know. It's something good to have in your head because quite often people will talk about a cubic centimeter it's the same thing in milliliters. So 50 cubic centimeters is the same thing as how many milliliters? 50, right? Okay, there's almost no math to do that conversion, right? All right. And then, oh, I guess I didn't have density on here, but let me write density in here since Brian said it. Density is grams per cubic centimeter. Okay, so it's a measure of mass per unit volume. And of course, we got things like velocity where we have meters per second also. So we can multiply and we can divide with the math, and we get units based on that. Okay. The next thing, you probably don't have to write all this down. Oops. Temperature. Okay. I'd say that the most important thing to know here to write down is going to be this. Temperature is the measure of the average kinetic energy of the molecules of a substance. Okay, a formal definition of what temperature is right there. And I think we've discussed this before, right, in class? What does it mean to have a higher temperature? It means that your molecules are going to wind up moving faster. It turns out we can predict heat flow by looking at temperature, because temperature is hot things. Because hot things move faster, have molecules that move faster. They tend to make other molecules move faster that are close by them. So we know that heat flow works through kinetic energy, through actually collisions. So when you touch something hot, what's happening is it's transferring a lot of the motion that's happening in it to your molecules, which are moving faster also. If you get the molecules moving fast enough, they turn from a solid into or from a liquid into a gas, and they expand greatly, which is why you get a blister. Ready to go on here, guys? Temperature units. Here's what you want to write down. Okay, I don't need you to know the Fahrenheit scale. That's in your textbook if you ever need it. What I think is most important here is that there's two temperature scales that we use in chemistry, Celsius and Kelvin. Okay, we use those two. The Celsius one is the one that we've got thermometers for. And converting back and forth between Celsius and Kelvin is real easy. We do a subtraction or an addition of 273. Okay. What you want to know, if you don't know it already, is water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. Okay. Room temperature in the room is 22 degrees Celsius today. So if you're trying to figure out what room temperature feels like, 22 degrees in here today. Okay. As far as converting to Kelvin, Kelvin always sounds really hot. Okay. And we're adding 273 to our Celsius temperature to get it. So 273 Kelvin is the same temperature that water freezes at. 373 Kelvin is the same temperature that water boils at. And since it's 22 degrees Celsius in the room today, it's 295 degrees Kelvin. Ooh, I made it bad. 295 Kelvin. Celsius and Fahrenheit, they both have degrees. Kelvin is an absolute scale. There's no degrees in it, so you just say Kelvin. Okay, so notice here, 0 degrees Celsius has a degree symbol. Kelvin, a lack of a degree symbol. That's done on purpose. Makes it easier to write, doesn't it? One less thing to write down. Last thing to talk about as far as matter measurements is concerned. Volume takes up the total amount of space. So you can measure volume one of two ways. The liquid measurement is milliliters. The solid measurement tends to be cubic centimeters, because we tend to measure solids based on length, width, and height, and volumes of liquids are easier to measure in a graduated cylinder. Note that conversion factors there again, doubly important, right? 1 milliliter is the same as 1 cubic centimeter. Mass, the formal definition, is that it's an amount of matter in a substance. Right? Weight has nothing, well, weight does have to do with the matter, but it also has to do with the gravitational interaction between it and the Earth. So your weight would change depending on where you were. If you go to the moon, you're going to weigh 1/6 the amount you weigh now. And if you've got the same pair of legs, that means you can jump 6 times higher on the moon than you can here. Lots of people, when they watch that the Neil Armstrong, they see how high he's bouncing and how much he doesn't have to put too much effort into that. Okay, he can't jump off the moon, but he certainly can jump quite a bit. What that means is that when the astronauts do go up to the International Space Station and they work on things like the Hubble telescope, if they interact with the Hubble telescope, they're moving along in the extra, what is it, the EMV, I think it's called, the thing with the gas jets. If they're moving along and they hit this Hubble Space Telescope, which one has more mass? The Hubble. Who's going to bounce? They're going to bounce off. Okay, so because the Hubble has more mass, it's not going to move, and they can't actually push it to move it. You talk about being in 0G, you think everything's weightless, it's going to be easy to move. It's not. The amount of mass that something has determines how hard it is to move. All right. Okay. So for the metric clown, here's the sort of work that you're going to wind up doing. Get the pen here so I can mark it. You see the top of the clown here? It says 10 millimeters, and they want you to figure out how many centimeters there are, right? What you're going to do is you're going to take a look at your prefixes and see what the difference is between millimeters and centimeters. Anyone remember what millimeters means? 10 to the what? -3, right? And centimeters means 10 to the -2, right? Okay, the difference between the two is a factor of 10 to the -1, right? So what that means I'm going to do is I'm just going to move my decimal points one place because it was a factor of 1 difference. Okay. Millimeters are smaller than centimeters, so I know I'm moving the decimal left. So 10 millimeters is the same thing as 1 centimeter. Should I go through another one? Okay. Let's see. I'll do the next part of the clown down here at the clown's hat. 100 meters is question mark kilometers. So 100 meters equals kilometers. Okay. Meters is a base unit, right? Did I cover that? If there's nothing, no prefix? I don't think. What's that? Right. So this is going to represent 10 to the 0th power. All right, since there's no base units, since there's no prefix on it, I should say, it's going to represent to the 0th. Kilo is times 10 to the 3rd, right? Okay. So the difference between 0 and 3 is 3. So I'm going to move my decimal 3 places. Which one's bigger, a meter or a kilometer? Kilometer's bigger, so I'm going to move the decimal to the left. Okay, since my meter is the smaller. 1, 2, 3. I'm expecting that number to appear small, right? So 0.1 kilometers is going to be the same thing as 100 meters. So I'm going to put 0.1 here, and I'm going to put 1 there. Okay, that's going to help us to determine what color to color these things. So the top of the hat, the answer of 1 is going to get colored blue, and the answer of 0.1 is going to get colored yellow. So I could pull out a blue marker here, and I could color, oops, that's yellow. All right, let me erase that. I thought I changed it. So you're going to wind up coloring the blue, top part of the hat blue. Don't mind my messy handwriting. And this part, at least, is known to be yellow.